Hi everyone, this is Mrs. Hutchinson, and today we're going to continue with scientific measurements. More explicitly, we're going to simply talk about temperature conversions. We're not going to really talk about the differences between heat and temperature, or really what heat energy is. In this particular video, we will do that later. Now we're just really going to focus on the equivalency statements and how to convert from one temperature unit to another, or from one heat unit to another. You'll need reference table T, so if you don't have reference table T, please take that out so you can take a look at it. You can pause the video while you do so. So, continuing on. Common temperature and heat conversions. It's very common in chemistry to have to convert between Celsius and Kelvin temperature units, and the good thing is that reference table T has that conversion factor for us, and it's relatively simple. And it's defined. So the conversion factor is written right here. We've got K stands for Kelvin, degrees C stands for degrees Celsius. And for this particular example, if we wanted to convert from degrees Celsius to Kelvin, we would use this particular equation. All you have to do is take your degrees Celsius amount and then just simply add 273 to that. So here's what I'm talking about. Here's an example. Let's just say we have 25 degrees Celsius. That's what's given. We want to convert that to Kelvin. So all we're going to do is use the formula. We're going to solve for something in Kelvin. We're going to place our temperature in degrees Celsius where it says degrees Celsius. So we've got 25 plus 273, which is going to be equal to 298 Kelvin. Pretty simple conversion, not too bad. Again, you just actually take your degrees Celsius temperature and plug it right into the equation. You can also use this equation if you wanted to solve for a degrees Celsius temperature. All you have to do is simply rearrange the equation. Okay, so let's take a look at this. So if we wanted to rearrange the equation here, solving for degrees Celsius, all we have to do is simply subtract 273 from both sides, and we would get our Kelvin temperature minus 273 is equal to our degrees Celsius temperature. So, let's do an example. Let's just say that we had 303 Kelvin. We wanted to convert that to degrees Celsius. So, let's plug it in to our equation that we had just created. So we've got 303 minus 273. It's going to equal our degrees Celsius temperature, and hopefully that comes out to be 30 degrees Celsius. Now, you don't necessarily have to rearrange the entire formula if you don't want to, and here's what I mean by that. You can simply take our formula that's given right here. Let's just say again we're sticking with 303 Kelvin and we want to convert that to degrees Celsius. We could just take that value, plug it into our actual equation, equals degrees Celsius plus 273, and simply solve. Subtract 273 from both sides, and you would wind up with 30 degrees Celsius. Okay, so there's really no need to actually solve for a degree Celsius, but I wanted to show you both ways and both methods for actually just plugging it into this one equation, or you can rearrange the equation itself and solve. Whatever is easiest for you. So that's how you would convert between Celsius and Kelvin. Pretty simple conversion, which is nice. So now we're going to move on to our heat energy. So two units for heat energy would be calories or joules, and the conversion factors for these are not given on your reference tables. In fact, If you were asked to convert between, say, calories and joules or kilocalories and kilojoules, I would have to give you those conversion factors. You would just be responsible for knowing how to use them. So we're going to use these conversion factors or equivalency statements in the same manner that we have for all of our conversion factors. So I would again have to give these to you, but these conversions are 1 calorie equals 4.2 joules or 1 kilocalorie equals 4.2 kilojoules. So now what I want to do is let's go right to our worksheets for temperature and heat units. So for converting into degrees Celsius, the formula that we're going to use, we're talking about our temperature formulas. You can get it right off of our reference table, and it would be Kelvin equals degrees Celsius plus 273. And we would want to rearrange that to solve for degrees Celsius equals Kelvin minus 273. Okay, so let's go ahead and do that. So we'll use this particular formula. Again, if you're really comfortable with plugging it into our original formula, go right ahead and just simply subtract 273. So we've got degrees Celsius equals 500 minus 273, and our answer comes out to be 227 degrees Celsius. Okay, not too shabby. Skipping down to question 2, so you want to do the rest of them, you want to do B through F using that particular formula. Of course, have your calculator handy, it'll probably make things a little easier. Next, we're going to convert into Kelvin, and the formula to use would be K equals degrees Celsius plus 273, the one right off of our reference tables, which is kind of nice. All we have to do is then take our degrees Celsius value and simply plug that into the equation. So our answer for this one winds up being 373 Kelvin. So then go ahead and do the rest of those, B through F. I want to also show you examples going through the rest of the problems. So let's just do those and then you can go back and finish it, or you can pause the video, finish up questions 1 and 2, and then move on to questions 3, 4, and 5. It's up to you. So now we're going to convert into joules. The conversion factor to use is something that I have to give you. 1 calorie equals 4.2 joules. I have to give that to you. That's not something you're expected to know. But what you are expected to know is how to use an equivalency statement when you see it. So 400 calories we want to convert to joules. So that becomes our given. Whenever we're doing a conversion, we use our T-chart. So let's write our given in the upper left, 400 calories. We're going to be converting from calories to joules, so using our conversion factor up here, we're going to write calories down in the lower right so they can cancel out. We're going to have joules in the upper right, because that's what we're converting to, and now we're simply going to place the values in front of the appropriate units. So we've got 1 calorie on the bottom, 4.2 joules on the top, and we're multiplying straight across to get 1680 joules. Not too bad. Again, if you're not comfortable with conversions, check out our metric conversions video, multiple metric conversions video, and metric to non-metric conversions video. It explains things pretty well, which is nice. Let's move on to an example from question 4, and then we'll move on to an example from question 5. So question 4, we're going to convert into kilojoules. So this one is definitely a little tricky, but again, it's something that we should know how to do. So we're starting off with calories, which means the conversion factor that I would have to give you would be 1 calorie equals 4.2 joules. But the question states converting into kilojoules. So that's where reference table C comes into play. So you're going to take a look on reference table C, look at the prefix kilo, and make the appropriate conversion factor. I'm not going to show you this here because I've shown you that plenty of times in other videos, so I'm simply just going to make the appropriate conversion factor here. If this is something that you still are struggling with, check out the other videos, fast forward to the conversion factor section, and that'll help you understand it. So converting from joules to kilojoules, kilo is just a prefix, so we would use 10 to the third joules equals 1 kilojoule. And again, that's right off of reference table C. So now we're going to have our multiple conversions table. Going to place our given in the upper left, so 50 calories. We are then going to place the conversion factor that has calories in it and place that in the appropriate box or segment. Calories is going to go down here so it can cancel out. Joules is going to go up top. Place the appropriate numbers in front. We'll have a 1 in front of calories, 4.2 in front of joules. Now we're into joules, but we need to convert all the way to kilojoules, so we're going to use the next conversion factor. Placing joules in the bottom right so that'll cancel out. Kilojoules in the upper right and placing the appropriate values in front. And then we're going to multiply straight across. So 50 times 4.2 times 1 divided by 10 to the third. And that is going to give us an answer of 0.210 kilojoules. So 0.210 kilojoules. Okay. Again, if you're confused about any of these two conversion factors or how I got them, I had to give you the 1 equals 4.2 conversion factor, but the second one, if you're still confused on reference table C, go check out the other video. Last but not least, let's check out question 5. And we want to simply convert into calories. So our conversion factor that we're going to use, I again would have to give you, so 1 calorie equals 4.2, you probably have memorized that by now, joules. We're going to draw our T-chart in. We're going to place our given in the upper left, so 2,000 joules. Using our conversion factor, we're going to place joules in the bottom right so that it can cancel out. And then we're going to place calories on top, placing the appropriate numbers in front of the appropriate units, so 4.2 joules, and a 1 in front of calories, multiplying straight across, so 2,000 times 1 divided by 4.2 is going to give us an answer of 476.2 calories. Okay. If you're still struggling with conversions, go and check out the videos. I know I've said that a couple of times, but I just want to reiterate that it is important. Okay, so go ahead and finish the rest of the questions on this particular worksheet, and I will see you with our next video.